Catherine deposits 100 into an account at the beginning of each 4-year period for 40 years. The account credits interest at an annual effective interest rate of I. The accumulated amount in the account at the end of 40 years is X, which is 5 times the accumulated amount in the account at the end of 20 years. Calculate X. So you see my diagrams right here. This represents the first 4-year period, the second 4-year period. So what is the accumulated amount at the end of 20 years? So she's going to put 100 in right here, 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 and here. Now, we're not going to include this, and all of these are going to accumulate to the end of 20 years, okay? Now, I'm not going to include this 100 right here because that's would be in the beginning of this period, of this, third, fourth, fifth, sixth, fourth year period. And that's going to be right after the end of the 20th year. It's sort of like this right here is maybe January 1st, deposited on the 21st year. So I'm not going to include that. So think about that. It's a little tricky. Okay. So at the end of the 20 years, right? I know my accumulated amount is, got to be familiar with these. It's going to be one period after the last payment. So it's going to be S double dot, and I have 100, and I have 5. Now, it says I is the 1-year interest rate, but I'm going to let this it's not important in this problem, and I could even let it be P. Okay. I'll just say it's P. Okay. Interest rate of P. Accumulated value is that. Okay. Now, at the end of 40 years, it's going to be a series of 100 payments. And for the same reason as before, we're not going to include this payment right here. That's going to be officially on this time period, and that's going to be too late. So all of these are going to accumulate to time here. So after 40 years, the solution is, or the accumulated value is 100 S double dot 10 at the 4-year interest rate, which is P. Okay. So it's the 4-year interest rate. Okay. Okay, great. Now this equals X, right? And this has to be, it's 5 times the accumulated value out of 20 years. So this has to be X over 5, right? Fantastic. And now we can set up an equation. So if I multiply this by 5, it has to equal this. So I'm going to say 500 S double dot 5 angle P equals 100 S double dot 10 angle P. Okay, so these are going to cancel out. And then I get 5. Right, I don't know what the interest rate is, so I say 1 plus P to the 5 minus 1 all upon D. It's going to equal 1 plus I to the 10th, 1 plus P and then all over D. So these cancel out. And then I'm left with this, 5 equals 1 plus P to the 10th minus 1 all over 1 plus P to the 5th minus 1. Now we can use a difference of squares here. So I get 1 plus P to the 5 minus 1. And then I get 1 plus P to the 5 plus 1 all over 1 plus P to the 5 minus 1. So these are going to cancel with this. So now I'm left with 1 plus P to the 5th plus 1 equals 5. So 1 plus P to the 5th equals 4. So we can raise both sides to the 4/5 power. 1 plus p equals 4 to the 1/5, right? And then we want to subtract 1. So what's that? 4 to the 0.2 minus 1. So p is equal to, the 4-year interest rate is 31.9%. Okay, and this is what I want. This is going to be the accumulated value that I want. So that's going to be equal to 100. Remember the formula? And it's going to be 1.3195 to the 10th power minus 1 all upon 0.3195. I'm aware you could use a financial calculator for that, but it's really not too bad to just put all this in there, okay? So let's go ahead and do that. So 1.3195 to the 10th power minus 1 divided by 0.3195 multiplied by 100, and we get 4,694.53, which is this answer right here. Okay, so you got to be familiar with this, a double dot angle n, s angle n, and then s double dot angle n. Okay, so you can read about that. There's many resources for free online about that.